right, so we see the normal curve on this page, but we're going to learn a little bit more about it, about the information that it provides. So we know the mean is the average, and we know that the mean number is in the middle of the normal curve. So down here we have a distribution of heights, and you can see that the mean is in the middle. The standard deviation does describe the spread of the data, and the normal distribution is a distribution that can be described by this curve, where most people are in the middle, and as you get farther and farther from that mean, you have fewer and fewer people. So heights are really a very good example of this. All right, heights are a really good example of this because most people have an average height, and some people are a little taller and some are a little shorter, and then some people, but not many, are a lot taller or a lot shorter. So heights are normally distributed. There are certain percentages of people that land within 1 or 2 or 3 standard deviations of the mean. Here is the mean in the middle, and this is true not just for heights, but for anything that's normally distributed. The mean's in the middle, and then this is 1 standard deviation above it, this is 2 standard deviations above it, and this is 3 standard deviations above. On the left side, we have the negative standard deviations. One below is -1 standard deviation, -2 standard deviations, and -3 standard deviations. So just looking at this curve, without even looking at the numbers, you can see that almost everyone is between -3 and +3 standard deviations from the mean. Almost everyone. And that's this here, the 99.7%. So 99.7% of people have a height that is within 3 standard deviations of the mean, either above or below. Everyone's in here, except for that 0.3%. 68% of people are within 1 standard deviation of the mean, so between 1 below and 1 above, and 95% of people are between 2 standard deviations below and above the mean. You can take that 68%, sorry, it's up here. You can take that 68% and then realize that that means half, 34%, is going to be 1 standard deviation below the mean, within 1 standard deviation, and that 34% here within 1 standard deviation above the mean. So I'm just taking these numbers, cutting them in half to get these numbers. The 13.5% here, that reflects just the people in this section. So if I know that 95% are within 2 standard deviations of the mean, and I subtract out the 68% that are in the middle here, then that would give me 27% of people that are in these two. And since there's 2 of them, I can divide it by 2 to figure out that there's 13.5 in each one. And you can do the same thing here with that 99.7%. So you can figure out what percent of people are in each section. And in the specific example down here, the specific example is the heights of adult American males. We know that the mean is 69.5 inches, and the standard deviation is 2.5 inches. And so that's telling us that 68% of people are between 67 and 72 inches. So I want you to think about these first 2 questions. They're kind of tricky. The first one says, where do you see the mean of 69.5 in the graph? The second one says, where do you see the standard deviation of 2.5 in the graph? Now remember that standard deviation is describing how spread out things are. So take a moment and see if you can find this number, and then this one's a little trickier to find. All right, so we found the mean right here in the middle. And the standard deviation, we said, is what you add to get to the next number on the right, and then you'll subtract it to get to the next number on the left. Okay, so add 2.5 to the mean to get to the next number. Or I'll call it the line. and then subtract 2.5 to get this way. 50% of American males are shorter than what height? 50% is half, right? So here's half. 50% are shorter than what height? It is 69.5 because this is the mean height. So 50% are shorter than 69.5 inches. And this one's a little trickier. 84% of American males are shorter than what height? So we know this is 50%. And if we add on 34 here, that makes 84%. So 84% are shorter than what height here? 72 inches. Good. Make sure you have this page done. All right, so you guys told me to put the mean of 1,000 in the middle. And now the standard deviation is 200. Should I write 200 right here? No, because that doesn't make sense. 200 is not more than 1,000. What numbers should I put here, Anna? What numbers should I put right here? How'd you get 1,200? Yeah. Okay. So Anna added 200 to get to 1,200. And we just keep adding, right? Sophie P., what would be the next one? Excellent. And then we'll get to 1,600. All right, on this side, you're going to subtract 200 each time. So take a moment to see if you can fill in this side, subtracting 200 each time. Okay. All right, so we took the mean and we put it in the middle. And then we took the standard deviation and we added it each time on the left and subtracted it. Sorry, added it on the right and subtracted it on the left. It says what scores land within one standard deviation from the mean. So remember, this is your mean right here, right? And then this is plus 1 standard deviation. And this is minus 1 standard deviation. And so your scores are right here, 800 to 1,200. Okay? So anybody who scores between 800 and 1,200 on the SAT, they scored within 1 standard deviation of the mean. That's pretty much like a middle SAT score. What percent of scores are more than 1,200? So this time they're asking about percent. What we're going to do is find those percents on the back because those percents, they always work. Okay? So more than 1,200 means this section and this little tiny section here. So let's go back and see what those were. It was this one, 13.5, 2.35, and 0.15. So we're going to take those numbers and label them here. 13.5% plus 2.35% plus 0.15%. Now when you add these in your calculator, don't put the percent. I think that will confuse Desmos. Just do them without the percent. 13.5 plus 2.35 plus 0.15. I didn't record that. So just to review, what we added was 13.5%, 2.35%, and 0.15% to find the percent of scores more than 1,200. The next one is the percent of scores between 800 and 1,400. So that's this section, and this section. I already know that this is 13.5%. I'm going to label these two. So those both say that they're 34%. I'm going to put those in there. 34%. 34%. And I'm going to add 34, 34, and 13.5. Okay, so take a moment and add those up and see what you get. Guys, you're going to want to know this for your exit ticket that's happening very shortly. I'm getting 81.5%. Can anybody confirm that? Excellent, thank you. Okay. Okay, so ACT scores are normally distributed with a mean of 21 and a standard deviation of 5. What number do I put in the middle? 21, excellent. All right, after that, it does not make sense to put 5 because 5 is a smaller number, but I use the 5, and what do I put? 26. That's what you got, right, Emmanuel?
Yeah,
You did? What'd you get for the next one?
31.
Beautiful. And Solomon, did you get the one after that? Lovely. All right, so we added 5 each time, right? On the left, we don't add, we do what? Subtract. Good. Tarek, you with me? So we're going to subtract and get 16 and then 11 and 6. Beautiful. All right, those are scores. Those are ACT scores. What scores land within 2 standard deviations of the mean? So this is the mean. This is 1 standard deviation, and this is 2. But I also have to go 2 below. So this is -1 standard deviation and -2 standard deviations. So between 2 above and 2 below, I'm getting 11 to 31. Did anybody else get 11 to 31? Good? Good. So the scores between 11 and 31 are within 2 standard deviations of the mean. And that's 95% of the scores are going to be within 2 standard deviations of the mean. What percent of scores are less than 11? This one, we're going to want to go back and look at these numbers here. Now I don't have to copy all of them because I don't need all of them, right? Less than 11 will be these 2 sections here. So that would be 0.15% and 2.35%. (0.15% plus 2.35% gives me 2.5%. Okay, so not a lot of scores below 11. What percent of scores are between 16 and 26? So 16 to 26. We have to get those numbers on the front, right? Let's give people a second because some people are still writing that.
Does that say 0.15%?
It does, yeah, 0.15% plus 2.35%. And I got those numbers from the front. Those percentages work for any perfectly normal distribution. Now, most distributions are not perfectly normal, so it's an estimate, but it's a pretty good estimate. What percent of scores are between 16 and 26? That's these 2 middle sections, which is 34. Oops, so you can't see it. 34 and 34. And that gave us what percent? 68. Good. Okay. Make sure your notes are complete.